Okay, sorry, I accidentally unmuted myself. I accidentally muted myself. Let's go on to the next one. That's it. There's basically nothing to it. Integer addition and subtraction. Now we're going to go on to integer multiplication and division. Multiplication and division rules are exactly the same. Positive divided by positive equals another positive. Negative divided by negative equals another positive. So let's just use an example for this. So let's say that we're doing 6 divided by 2. 6 divided by 2 is 3. And negative 6 divided by negative 2 is also 3. So if the signs are the same, see right here, this says it, okay. Same sign equals positive, different sign equals negative. It says it right there in the purple box thing. Okay, so yeah, that's basically the thing. And multiplying is also the exact same thing as division, except you're multiplying the thing. So let's say that this is 6 and this is 2. 6 times 2 is 12. Negative 6 times negative 2 is also 12. 6 times negative 2 is negative 12. And yeah, so on and so on. Okay, identical sign equals positive answer, different sign equals negative answer. Okay, so practice, we're just gonna do, let's see how many people, okay, we're gonna do the first 13 problems of this. So yeah, that's it. So first off, I'm gonna do number 1. Let me get my annotation tool. Okay, here we go. Okay, so there we go. Negative 18 plus 6 is negative 12. Let's go on to Jinan or Jinan. I don't know how to pronounce your name.
Well, it's Nan, but the G is silent.
Okay, Nan. You can do number 2.
That's negative 2.
Okay, good job. Let's go on to Manya. Manya, you can do number 3.
Sorry, my mic wouldn't unmute. Number 3 is positive 16.
Number 3 is actually negative 2 because this is a
I
subtraction
don't see the
sign.
minus sign.
Okay, yeah, this answer is also wrong because there was a division sign, not an addition sign. It looked like an addition sign, but it was actually a division sign. So negative 18 divided by 6 is negative 3. Okay, so I fixed my answer. And let's go on to number 4. Number 4 goes to Middleish. Middleish, you can do number 4.
Yeah. -5?
No, yeah, yours. The answer is 5. Yeah, good job. Mitish, you can do number 5. Hello, Mitish, you can do number 5. This one.
I think it's a 1.
Why do you think that it's a 1?
Like -3 times +3 equals 1.
Okay, it's actually negative 9. So basically what's happening here is 3 times 3, you just do that first. 3 times 3 is 9. And this has, these signs are not the same, so it's going to be a negative answer. So that's basically how you do it. It's actually negative 9, okay? So good job anyway, good attempt. Okay, Namrata, you can do number 6.
-5 and +5.
This is actually a multiplication sign. Can you guys see that?
Yeah, I could see it. +6.
Yeah, good job. Okay, so we're gonna go on to number 7. Neil, you can do number 7.
Okay, so number 7, right? Wait, hold up.
Yeah, number 7.
So it's -2 times -7, right? Parentheses.
No, it's this one right here.
Oh, wait, we're doing that one?
Yeah.
Okay, so that, okay. Sure, I'll be able to do that. Just let me calculate.
It's -30 divided by -6.
Okay, got it.
Hello, Neil, are you here? I couldn't hear you. Did you say your answer? Okay, that seems like a no.
Oh,
so
wait, no. Is it 5?
Yeah,
Okay.
it's 5. Good job. Okay,
go.
so we're gonna go on to let me just scroll down here. Okay, we're gonna go on to Pranav. Pranav, you can do number 8. Hello, Pranav, are you here?
Yes. Yes.
Yeah, you can do number 8.
Okay. Number 8 is 8.
Yeah, good job. Okay, so we're gonna go on to number 9. Number 9 goes to Rakshit.
It's 7.
Good job. Okay, Ritvik, you can do number 10. Okay, seems like Ritvik is not here. Let's go on to Rohanata Visa. You can do number 10. Rohanata Visa, you can do number 10.
Number 10 is +2.
Okay. It's actually -8 because as you can see, there's -3 over here, and you're subtracting 5. So since they're the same sign, they're gonna equal a smaller number. Not really. They're gonna equal a bigger negative. Okay, since they're the same negative sign, and yeah, the rest of them get added. Okay. So that's gonna be -3 minus -5, and that's -8. Okay. Let's go on to number 11. Satvik, you can do number 11.
It's -8.
Okay, good job. Need to scroll down. Okay, so Dart, you can do number 12. Oops. So Dart, you can do number 12.
Okay. that'd be 2.
Okay, good job. And last one goes to Sujit. Sujit, you can do number 13.
It's 1.
I think it's actually 17 because that's 9 plus 8, so that's 17.
Rishabh, you got confused with number 10. It says like minus.
Yeah, there's a negative over here too.
No, there's a minus. You have to do -3 minus +5.
Yes. Yeah. So -3 minus plus. Okay, let's work this out. Okay, so you have -3 and you have minus +5. So minus +5. So subtraction is adding the opposite, right? So you can do so this turns into this turns into negative 3 minus 5, right? So now you're adding two negative numbers, and that equals negative 8.
Okay.
Yeah, good question though. Okay, so we're gonna go on to the next thing. So let me just clear everything. Okay, let's go on. Ratios, proportions, and percents. Okay, so these are pretty cool. Ratios are parts of a whole. They basically are fractions. They basically are fractions. So you can represent ratios using the word two. So let's say you want to do A to B, and you call this 2, and you also call this 2, or you can use fraction notation. So that's A to B, or you can use a colon symbol, A to B, and or you can use the fraction notation. So that's A over B, or A to B. It doesn't really matter when you're using fraction notation. Okay, so let's go on to the next slide. Proportions. So proportions are the equality of ratios. So ratios are these things that we learned earlier. And so proportions are basically the equality of ratios. This can involve variables. So variables are like something that represents a number. It can be a symbol, it can be like a letter, or anything like that. It represents a number that we don't know. Or maybe we do know it, it's just a really long number and we don't want to write it all out. So that's a variable. Actually, no, that's a constant. Okay, never mind. So these variables, they can be anything and we don't know the value of them, and they represent numbers. They can be a symbol or anything like that. So they can use, proportions can be used to solve certain problems. So let's look at what a proportion really is. Okay, so basically a proportion is the equality of ratios. I wrote that over here. And so it looks something like this. A over B equals C over D. Okay? So equation with 2 equals ratios. So 2 over 3 equals 4 over 6. If you simplify this, that's going to work out to be true. This one is also the same thing, kind of. Okay, so let's look at proportion like problems. Okay, so proportions can involve variables. I wrote that here. Okay, so this is x over 8 equals 5 over 16. Okay, so how do we solve this? Since this is a really simple problem, we can just solve it like using common sense. So basically, there's an 8 over here and a 16 over here. So I'm pretty sure most of you know equivalent fractions because those are taught in like 3rd or 4th grade or something like that. So equivalent fractions, for those who don't know, so basically 1 over 8 is the same thing as 2 over 16. 2 over 16 because you're multiplying you're multiplying both the top and bottom by 2. So you can do times 2 over here and times 2 right here. And that's what makes them both equal. So these are equivalent fractions. So using this, we can calculate the value of this. This is like simple common sense. This 8 and 16, 8 times 2 is 16. 16 divided by 2 is 8. So we can just do 5 divided by 2, and that equals 2.5. So x is obviously 2.5. Super simple. Let's go on to a more complex one, okay? So we're gonna do this one. Okay, so that's I'm gonna write it out. X plus 3 over 7 equals x minus 2 over 4. Okay. It's really hard to write with a mouse. I'm sorry if my handwriting looks really bad. It's because I'm writing with a mouse. And yeah, so that's 2, and that's an x. Okay, so how can we solve this? Basically, there's this one way we can solve it called cross multiplication. So basically, if you have like 2 fractions on both sides of an equation, you can multiply like this and like this. So 7 is going to go onto this side, 4 is going to go onto this side, and you can have x plus 3 times 4. So x plus 3 is going to be inside parentheses, x plus 3. You guys can write this down if you want. It would actually really be helpful if you took notes or something like that, so you don't forget. Okay, so 4 goes over here. Okay, that does not look like a 4. It looks more like a 9. Okay, so here's a 4. So 4 goes over here. You have 4 times x plus 3 equals 7 times x minus 2. Oops, okay. There we go. Okay, so these two are equal to each other, and so we can use the distribution property to like distribute this 4 over here, and we can distribute the 7 over here the same way. So 4 gets multiplied to x, and 4 gets multiplied to 3. 7 gets multiplied to x, and 7 gets multiplied to 2. So this becomes 4x plus 12 equals 7x minus 14. Okay, so this is a very important concept. So do all of you guys get this? Okay, that definitely sounds like a yes. That definitely.
Yep.
Okay, so we're gonna go. So we're gonna move on. We're just multiplying this 7 into both of these terms, also this 4 into both of these terms. And since these are equal to each other, we can use basic algebra to move move this to this side. So we can add 14 to both sides, and that's going to make this equal 27 on this side. And we can take 4x to the other side by subtracting 4x on both sides. So that cancels 4x on here. And it moves 4x over here. So basically you have 27 equals 7x minus 4x, which is basically 3x. So 27 equals 3x, and you can divide by 3 on both sides. Cancels this out. It's 27 divided by 3, that's 9. So x equals 9 for this problem right here. X equals 9, and that's the answer. So do all of you guys understand that? Sounds like a yes. Okay, so let's go on to percents. So percents are pretty cool. They're like a way of representing fractions or decimals. So how you can write percents is if you have a fraction, let's say a half or something like that, a half, you basically turn this into a decimal first, and then you turn it into a percent. So how do you turn this into a decimal? You can just use division. So 1 goes into here, and 2 goes on the outside. And how many times does 2 go into 1? 0 times. So you have 0, add a 0 over here because you put a decimal place over here. Then you can do how many times does 2 go into 10? That's 5. So, and you can put this over here also, and that makes this 0. Sorry, that's supposed to be a minus. I just wrote it wrong. Okay, so there's actually supposed to be a decimal over here, but it doesn't really matter if you put that because this doesn't really matter. This doesn't go into the final answer. You can do it however you want. Okay, so 1 divided by 2 or 1 over 2 is 0.5. I'm pretty sure most of you know that. Most of you should know that. 0.5. And now we can turn this into a percent. So as you can see, percent is a way to represent fractions or ratios. And I'm just breaking down what percent means here. So percent, cent equals 100. So percent means out of 100. So to get the out of 100 thing, you have to multiply this decimal by 100. So if you multiply this decimal by 100, it becomes 50. So a half, 1/2 as a fraction, or 0.5 as a decimal. Okay, that's one second. Okay, so a half as a fraction or 0.5 as a decimal equals 50%, or 50 out of 100. So yeah, here's a chart of like basic percents that you should memorize and their corresponding values as a fraction. Okay, so 1% is 1 out of 100, 10% is 10 out of 100, or 1 over 10. 20% is 1 over 5, 25 is 1 over 4. 33.3333 going forever is 1 over 3. And 50% is 1 over 2, like we just watched over here. This is a half. And yeah, so on and so on. Okay, so is everybody good with that? I'm gonna go on to the next slides. If everybody's good with that, okay. Seems like everybody's good.
Wait, I have a question.
Yeah.
So I don't get it how 66.6 is equal to 2 out of 3.
So you know how 33.33233 is equal to 1 over 2? I mean, sorry, 1 over 3.
No.
It says it right here.
Where?
Obviously, that right here. So obviously, that means if you multiply both of these sides by 2, then this becomes 66.66666 going forever, and this becomes.
Okay, but why is 1 by 3 equal to 33.3%?
Because, okay, Namrita, can you stop annotating on screen, please? Okay, so everybody, please stop annotating on screen. So yeah, so let's look at why this is. Okay, so let's. Okay, none. You can stop, please.
Or else he'll disable the annotation, and he can. Okay.
I did.
Oh,
Okay,
you guys weren't here. He can.
I already did just now. Okay, so 33.333. So that's 1 over 3, and so to turn this into a decimal, all you have to do is you have to divide it. So
Why are we turning it into a decimal? Do we have to turn it into a decimal?
yeah,
Why?
turn it into a decimal before you turn it into percent.
Can you do it times 100 by 100 and then you get a percentage?
Yeah, but that's the same thing as doing it like that. So it doesn't really matter.
Why aren't the others, except for 66.6%, have a decimal? They're all supposed to have decimals.
They all already
Percent
have decimals.
decimals.
See, there's a 0.0 over here, 0.0 over here, and 0.0 for all of these, which doesn't have an apparent decimal.
But
So
why does
any number that does not have a decimal in it always has a decimal of 0.0. That's the decimal.
It's always at the end of the number.
5.
You guys are all talking at once. I couldn't really hear any of you.
Well, like technically it's 0.75, not 75.
Yeah, but this is 75.0%.
Yeah, but like it's
Yeah, this
75.
turned into this turned into a decimal is 0.75. Yeah, you're right.
Yeah, so why is it 75.0 when it's actually supposed to be 0.75?
Because this is a percent. This is 75.0%. This and this are not the same thing. See, this has a percent sign. This doesn't. This is just a plain number. This is a percent. Percent means
But you said they all have decimals, so it's basically the same. And you're muted, I think. Maybe, yeah, you're muted, I think. Are you? Yep, you're muted. You are muted.
The other things don't have a decimal because they're even. Well, they do, but like they don't have like a legit decimal because like they're even numbers.
It's not because they're necessarily even numbers, but yeah, I get what you're trying to say. Okay, so basically
Can
why
we
this
just get back to the
why
point?
this is a 75.0 and this is a 0.75 is because this is an actual number
Okay,
when this is not. This is just a percent.
okay.
So percent means out of 100. So
So my first question was, how is 33.3% equal to 1/3?
okay, so that's because 1/3 is just a division. It's 1 divided by 3, so we can just calculate that. So, oops. So this is just going to be, how many times does 3 go into 1? Yeah, that's right, 0. Then we can put a decimal place over here, add a 0 right here. How many times does 3 go into 10? Yeah, that's right, 3. So we put 9 over here.
Well, if you
Times 3
add
is
1,
9.
yeah.
And then there's a 1 over here again, and then we have to like add a 0.0 over here also, and we have to keep going.
I know.
And this just goes on forever, so that's why it's
Yeah.
just 0.3.
Oh, so that's why it's just 3. That's why it says 3.
So when you divide it from the fraction to get converted into a decimal.
Wait, but is it 0.3333? 0.333 isn't equal to 33.3, is it?
Yeah, it's equal to 33.3%.
Okay.
Okay.
Now
The other person, I can't recognize you by your voice, but you were asking a question. You were asking a question before, Neil, like something about like dividing like a fraction, dividing or something like
I
that.
was just explaining it.
Okay. Okay. So thanks for the explanation. So we're a little bit behind, so we're gonna move on. Okay. So everybody understands this, right? Okay, that seems like a yes. We're gonna move on. Okay, practice. We're not gonna worry about this. This is super easy stuff. So I'm just gonna do an example problem. We're not gonna be doing any of the practices. So basically here, let's do number 2. Okay, so 20% of 100. Obviously, since a percent is out of 100, we can do 100 divided by 100 times 20. So that's a 100. It looks like 166, but it's actually 100 divided by 100 times 20. So let's do this. So 100 divided by 100, that's going to be 1. And 1 times 20 is 20. So that's how you get 20 over here. And that's all this complicated stuff. It's just one thing. Okay, so let's go into a little bit more complicated problem. I'm just going to do this one. Just clear the screen. I'm going to do number 7. So 40% of 150. So for this one, let's do this one. So that's 40 times 150 divided by 100. Okay, so with this, we can cross out these these zeros and these zeros. So basically, we're just dividing by 10 for each of these. This becomes 15 times 4. And obviously, that's 60. So this is 60. That might seem a little bit like magic and complicated, but all we're doing is we're basically factoring out the 10 from both of these. And since this is a 100 and 100 is 10 times 10, we're just crossing 10 and 10 out, and we're just canceling out this other 10 here. So this bottom becomes 1, and anything with a denominator of 1 is just a normal number. It's just a whole number. So that's 4 times 15 divided by 1. And that's 4 times 15. That's equals 60. So that's all we're doing. So does anybody else have any questions? How to take a percent of a thing? Okay, so now let's do an example of a proportion. So I'm going to do this number 2 one. It's a little bit hard to see, but what that says is something divided by 3 equals 16 divided by 24. So for this super easy one, all we have to do is look for common factors between 3 and 24. And obviously that's 8. So we can divide 16 by 8. That's a division sign. And that's a 8, not an infinity sign. Okay, so we can divide, sorry, this is supposed to be a times 8. And this is supposed to be a times 8. But since we're going backwards like this, let me just put an arrow over here. It's divided by 8. Okay, so now we can do 16 divided by 8. That equals 2. So that's 2 over 3. This right here is supposed to be a 2. But the answer for that is a 2. So yeah, that's super simple. I think everybody should get that. Okay, so ratios, all you have to do for this one is you have to do, so this says 18 pounds to, let me just clear the screen just a second, guys. So that's 18 pounds to 22. Okay, that's supposed to be an L pounds. So 18 pounds to 22 pounds. And now we just have to turn this into a fraction. This as a fraction is 18 divided by 22. And if you simplify that, it's going to be 11. This is going to become 9. All I'm doing is factoring out a 2. See 9 times 2 is 18. 11 times 2 is 22. And so if I just cross out these two 2's from the bottom and the top, then we're left with an 11 and a 9. And so this simplified down is equal to 9 over 11. Yeah, see, magic. Nice. So this answer is 9 over 11. That's the answer for 11. I mean, sorry, not 11, 1. Okay, so does anybody have any questions with that? Any questions with the proportions?
Yeah. I have a question on the ratios of weights. So you
Oh.
put it as a fraction as 9 over 11. Could you also put it as 9 to 11?
Yeah, you could also do that, yeah.
Okay.
But this says express each ratio as a fraction to the simplest form. So that's why I didn't do that. You have to always follow the instructions.
I couldn't see because it's really tiny.
Yeah, it was super tiny, yeah. We're going to go on to the next one. Okay, so exponents and square roots. So this is from day 2. And so exponents and square roots, let's go on to it. Exponents and square roots are pretty simple. So exponents, we're going to do exponents first. Exponents are to multiplication as multiplication is to addition. So you know how like, you know how addition is like repeated, sorry, you know how multiplication is repeated addition? Exponent is basically repeated multiplication. So yeah, that's super hard to understand, but so basically 2 to the power of 2. See this little tiny number? It's called the power. So 2 to the power of 2 is 4. And how we get that is you have to do 2 by itself this many times. So this only says 2. So 2 times 2 is 4. So now let's go on to 2 to the power of 5. This is actually 35 and not 10. It's not 10 because we're not doing 2 times 5. Or else we would have just written 2, oops. or else we would have just written 2 times 5. 2 times 5. If we wanted to do 10, if you wanted to do 2 times 5 to this. This is actually 2 to the power of 5, which basically means 2 times 2 times 2 times 2 times 2. As you can see, this is 5 times. 1, 2, 3, 4, 5. There's 5 times. That's why there's 5 over here. It's a repeated multiplication, and this is literally the only way to do exponents unless you use a calculator. So 2 times 2 times 2 times 2 times 2, that equals 32. As you can see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Okay, so yeah, that's exponents basically. And let's look at why 5 to the power of 2, however, is not equal to 2 to the power of 5. This is not commutative like addition and subtraction is. Sorry, not addition and subtraction. I meant addition and multiplication. You know how addition, let's say you have 6 plus 5. This is the same thing as 5 plus 6. This is called the commutative property. And this is basically just saying that this is equal to this written, but like the other way around. Exponents are not like that. If you have 2 to the power of 5, it's not going to be the same thing as 5 to the power of 2, which, by the way, is 25, because you're multiplying 5 2 times. So that's 5 times 5. That's 25. It's not the same thing as 32. So yeah, that's why 5 to the power of 2 and 2 to the power of 5 is not the same thing. Okay, x. So anything to the power of 0 is just 1, because it is. There's like a reason to it, but like I don't really want to explain it to you right now because we're on a really tight schedule. Just remember that anything to the power of 0 is 1. Always remember that. That rule is never broken. Okay, so exponent rules. These are basically the exponent, like order operations or something like that. They're the rules for operations of exponents. So the product rule, so this is a to the power of x times a to the power of y, and this equals a to the power of x plus y. And this is for multiplication. You don't do this for addition. So let me give you an example. So let's say you have 5 to the power of 2 times 5 to the power of, I'm going to write it in a different place. Okay, so let's write it over here. 5 times 2, 5 to the power of 2 times 5 to the power of 3. It is 5 to the power of 2 plus 3. And this is 5, so this is equal to 5 to the power of 5. So yeah. And this only works if you have the same base number. This is called a base. The big number, it's called a base. And if you have something like 2 to the power of 2 times 3 to the power of 5, you can't really do this. It's not gonna be 6 to the power of 7, because that's just not how it works. You can't really do this. You just have to work it out. So yeah, that's how this product rule works. The quotient rule is basically the same thing, but this time you're subtracting the exponents. So basically what you have is 5 to the power of 5 to the power of 3 divided by 5 to the power of 2. And so for this, you just make this one base and you subtract these exponents. So that's 3 minus 2. So that's the first number minus the second number. And yeah, this is just 1. So there's 5 to the power of 1 which is just 5. Anything to the power of 1 is that number itself. So yeah, that's one of those. And here's the 0 exponent rule. Anything to the power of 0 is 1. Anything that has a negative exponent, so something like 5 to the power of negative 5 or something like that. So 5 to the power of negative 5 is the same thing as 1 over 5 to the power of 5. So you see this has a negative, this over here does not. So that's what this negative exponent rule is saying. This is the power of a power rule. So basically what this is saying is if you have 5 to the power of 2, all of this to the power of 3, then you just have to multiply these two exponents right here, and you have to keep the space. So that's 5 to the power of 2 times 3, which is 6. So that's 5 to the power of 6, which if you work it out, I don't know what it is, but it's just like something like that, you know. So that's 5 to the power of 6. That's what this is. Power rule. That's what this is saying. So power of a product rule. Yeah, it's the same thing. It's like the distributed property, but it also works for like the individual variables and individual things on a term. So yeah, that's pretty cool. And yeah, that's basically it. There's the exponent rules. Let's go on to operations with exponents. So the basics of exponents. Basically, this is just what we learned last time. There's nothing new to it. So square roots, these are pretty cool. Basically the opposite of exponents. Exponents are repeated multiplication, and square roots are basically repeated division, I think. At least that's how I like to think of it. It's a little bit confusing, I guess. But this is just a thing of a table of square roots. So as you can see, the square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. So let's look at that. Let's look at the pattern in that. So you guys know that 2 to the power of 2 is 4, right? And 3 to the power of 2 is 9. And 4 to the power of 2 is 16. So do any of you notice a pattern here? There's 4 over here, 4 over here, 9 over here, 9 over here, 16 over here, and 16 over here. So do any of you notice a pattern here? Yeah, obviously you should. If you don't, well, here's the pattern. So basically, this 2 to the power of 2 is this. So this is how you calculate like these. So you have to. So if you're given like a square root of like some number, let's just say 25, square root of 25. What you're supposed to think of first is this is a square root sign. It's really bad, but so what you're supposed to think of first is what multiplied by itself equals this number. That's basically how you should approach this. So 5 times 5 is 25, and 5 times 5 obviously is 5 squared, or 5 to the power of 2, right? So yeah, this is pretty.
I have a question.
Yeah.
So in this table, what the answer of the square root is. Say if you didn't give the answer, do you have like a formula or something to figure what the square root is?
Kind of, but no. Okay, so what I mean is, so basically, if there's a perfect square number, which means like you can multiply something by itself to get the number, then this is what you get. But if you don't have something like that, let's say you have 65, then you don't have something like that. Yeah.
Okay. Square roots are almost like exponents, right?
They're the
They're
exact opposite of exponents, so yeah, kind of they're almost the same thing.
not exact opposite, it's almost the same. But only
Excuse-
slightly a bit.
It's let's just say that exponents are multiplication. So exponents and so square roots are to exponents as division is to multiplication. They're opposite operations. I mean, not exponents. Sorry, the squares. Square roots are to squares
Okay.
as multiplication is
How
to
flashy
division. Kind
is
of.
this light?
Okay, Neil, can you please stop doing that? You're just disturbing the class with that light. Okay, so Manya or whoever asked that question, I can't really recognize you by your voice, so sorry about that. If
I
I'm
can
wrong.
ask the question.
Okay, so basically, if you have something like square root of 65, then there is a way to find it out, but I don't know that way. The easiest way to find this out is using a calculator.
Can you use the long division method to find it out?
Yeah, I'm pretty sure there's something like that, but I don't know how to use it.
But you can use it to figure it out, right?
Yeah, I think so.
Okay.
But you're gonna have to search it up by yourself. I don't really know what that is. If you really want me to, I can show you it next class, maybe. But yeah, that's not really the focus of this class, though. So yeah, I'm not gonna be going over that. Like in depth.
Okay, so we have next class tomorrow, right?
Yes.
Okay.
Okay, so we're not going to be going over this practice. We're just going to be looking at it. So basically, exponents worksheet.
Yeah, we're just looking at it, right?
Yeah, so this is 1b. So let's look at 4 to the power of 2. So 4 to the power of 2 is 16 because 4 to the power of 2 means 4 times 4. That's 16.
Wait, when's next class?
Tomorrow,
Oh, okay. What time?
same time, 7 to 9.
Okay. Wait, so it's every day?
Yes, for the
Oh, okay.
for these 2 weeks.
Same link, right? Same link?
Yes,
Okay.
unless otherwise notified.
Okay, cool. You got high five. Oh, I mean high 10.
Okay, so basically, let's go on to number 2a. So 0.3 to the power of 1, that's just 0.3 because this has an exponent of 1, and anything to the power of 1 is itself. So now let's look at a decimal to the power of 2. So 0.6 to the power of 2 is basically 0.6 times 0.6, all we've been doing so far. And if you calculate this, it becomes 0.36. If you
This
haven't learned, if
a
you haven't
bit
learned
past
decimal, okay, Neil, can you please, unless you have a question, Neil, can you please be muted? So,
Okay.
0.6 times 0.6. If you haven't learned decimal multiplication, well, it's just like this: 0.6 times 0.6. Just ignore the decimals. Sorry, this is supposed to be a 6.
Wait,
Okay,
how
so
long is every class?
2 hours, 7 to 9. Okay, so just ignore these two. Just ignore the decimal and 0. And just do 6 times 6 first. That's obviously 36, right? Yeah. So now let's look at the total number of places to the right of the decimal. So as you can see, there's a decimal right here and a decimal right here. And there's in total 1 place and 2 places to the right of the decimal. So we need to put a decimal right here. See, decimal is normally over here. We need to move it 2 places back because there's a total of 2 places right here. So this is where the decimal is going to be. So that's the decimal. So this is going to be 0.36. Okay, so that's how you do decimal multiplication. If you haven't learned that, then it's going to be pretty complicated for you to understand the rest of this stuff in this class. If you don't know decimal multiplication, then it's going to be pretty hard for you to understand the stuff in this class. So yeah, sorry about that. So let's go on to equations. So this is the exciting stuff. So expressions and equations. Equations is made up of expressions that are equal to each other. So an expression is something like x plus 5 plus 3 plus 5 plus x squared, or x or x plus 2. So like this whole thing is an expression. This thing can be an expression, and this whole thing right here is an expression. Just x, it's an expression. Even though it's only a variable, it's still an expression. It still can be called an expression. So yeah, an equation is two expressions that are equal to each other. So let's look at an example of that. So basically we have like x plus 5, okay, my handwriting's really bad, equals x minus 2. So yeah, this is an equation. We're going to be looking at how to solve them later, or sometimes.
Yo, so like we're just like learning the basics for now, right?
Yeah, we're just reviewing what we did. We're just reviewing what we learned last class, if you were here last class. So this is the parts of an equation. You have, this is called a term because there's only multiplication and division. There's no addition in here. If you have an addition, then this other addend is another term. Terms don't have addition or subtraction in their things. So yeah, this is an expression, obviously, and this whole thing is an equation because this is also a different expression, and these two are called constants because they don't have a variable attached to them. And so this unknown thing is called a variable, as you can see. And this 3 attached to the x is called a coefficient. And coefficients are multiplied to variables, even though it does not seem like it. Even though there's like nothing in here, even though there's nothing here, because these two are a number and a variable, if there's nothing in between them and they're just like super close together, then that means they're being multiplied, okay? So yeah, those are the parts of an equation. Expressions and equations, that's pretty cool. Let's go on to one-step equations. So how do we solve these super easy one-step equations? So one-step equations are just these. See example, 3x equals 6, solve for x. So we can just divide both sides by 3 to cancel out 3 over on this side, and we can divide by 3 on this side to get the answer on this side. So this cancels out 3 and 3. That makes it only x. This isolates x, which is exactly what we want to solve for x. Then we can do 6 divided by 3, which is 2. Okay, so x equals 2. So yeah, what time is it? 6. Oh, I mean, sorry, 8:06. Once it's 8:10, we're gonna have a small break, 2 or 3 minutes maybe. So yeah, that's x equals 2, and that's how we solve one-step equations. These are super duper easy, and yeah, they're super simple. Two-step equations, they're a little bit harder, but they're basically the same thing. You just have to. Okay, so let me show you. Let's try to solve one of these. Okay, so we have an example right here. 5x plus 12 equals 13. So to solve this, we're going to have to use basically the reverse order of operations. So when you're dealing with stuff going to the other side and getting canceled and stuff, you always want to do like you always want it to do in the order of reverse of order of operations. So basically, the order of operations is PEMDAS. So right now you're gonna have to do PEMDAS. This is the normal order of operations, right? PEMDAS. We're gonna have to do SAD MEP or something like that, you know? SAD MEP. These two are grouped. These two are grouped. So SAD MEP, we're gonna have to do SAD MEP, which is basically the reverse order of operations used when you want to cancel stuff and solve equations. So we want to do addition and subtraction first. So to cancel this term, we're going to have to do minus 12 because this is a positive 12. If we subtract 12 from it, then it becomes 0 because 12 minus 12 is obviously 0. And 0 plus anything is like that same thing. So it's basically effectively canceled. So this one's done. This is canceled, moves over to this side. You have to subtract 2 from this side also because whatever you do to one side, you also have to do to the other side to keep the equality. So we're going to have to do 13 minus 12, that's 1. And you have 5x equals 1. Okay, so now this is just a simple one-step equation. All we have to do is divide by 5 on both sides because this 5 is being multiplied to x, and we want to make x go all the way by itself. So we're going to have to divide by 5 on both sides, divide by 5 on this side, and divide by 5 on that side. This gets canceled, and what we have left is x equals 1 over 5. Okay, so yeah, let's take a small break right here. We're going to go on to multi-step equations in just a few minutes. So yeah, you guys have 3 minutes for a break.
Why is nobody talking?
It's break time.
Okay, so guys, is everybody back? Oh, it's been way longer than 10
Yeah.
minutes. Okay, so let's keep going. Okay, so does anybody have any questions over what we covered in this half of the class? That seems like a no. So I'm gonna move on. If you have any questions, you can ask anytime. Okay, so multi-step equations. So it's greater than 2 steps, and it's even harder. So basically, with multi-step equations, you have stuff like the distribution property and stuff like that, and more complicated stuff in general, like addition, subtraction, and weird things. So basically, let's try to solve this problem right here. So first, what I notice is there's 2 common terms right here. This is negative 15x and 5x. So common terms are where you have like the same variable with the same degree, which is the exponent with the same exponent. So these both all obviously have the same variable, and they obviously have the same exponent, which is 1. So there's an invisible 1 as the exponent. So that's good. We can add these two together. So 5x minus 15x is negative 10x plus 12, which we got from here. That looks like a plus. It's supposed to be an x. Let me just clear the screen. Okay, so that's 10. Okay, that's 10x plus 12 equals. Next, what I notice is the distribution, the 2 times 5x minus 9. Okay, so we're gonna have to simplify this by itself. So this equals 2 times 5x. That's 10x. Okay, and let's see, minus, so that's negative 9 times 2. That's negative 18. And yeah, that's what we have. That's the first step. Let's go on to the next step. Okay, so the next thing I'm going to have to do here is okay, guys, sorry about that. I accidentally muted myself. But basically, this is negative 10x. I just noticed, because it's 5x minus negative 15x. So yeah, that's negative 10x. So yeah, let's keep going. Okay, so that's still the first step. So let's keep going with this. The next thing we're gonna have to do is isolate x on one side of the equation, or yeah, and isolate these two so we can solve it. So let's see the easiest way to isolate this. Since I want it to be the easiest way, I want everything to be like positive before we divide and like do everything. So I'm gonna add 10 to both sides to cancel this negative 10 over here. So if I add 10 to both sides, this is gonna get canceled, and there's gonna be a 20x over here. So this becomes 20x. Then this negative goes on to this side also by becoming positive 18, and this gets canceled. We add positive 18 to both sides. This gets canceled. 12 plus 18 is 30. So 2x or 30 equals 20x. So now we can just like divide by 20 on both sides. So divide by 20 on both sides. And you cancel out this 20 right here. And you get x equals 30 over 20. Or simplified, it becomes x equals 3 over 2. This is the answer that we get. So yeah, that's it. That's how we solve this. Lots of steps, but we finally got to an answer. So that's basically what multi-step equations are. So yeah, let's keep going. Let me just clear the screen. And yeah, so this practice. It should be pretty easy for all of you. So I'm not gonna do this. More practice.
Rishabh,
Yeah.
practice or homework?
You guys don't have any. You guys don't have to do any homework for this class. No homework.
Okay. For this class or like next class, do we have to do it?
For this whole course, you don't have any homework. This whole course. Yeah. That doesn't necessarily mean that you shouldn't practice. You guys should always practice the stuff that we're learning in class by yourself. But there's no like assigned homework. You guys don't have to show me anything. You guys can practice on websites like Math Aids or websites like those where you can get like free worksheets and stuff, like Kuda software or something like that. Yeah, I'm gonna share those at the end of the class maybe if we have time. But that's where or you can just like search on Google like equations practice sheets or something like that. Equations practice worksheets or something. Just keep practicing, but there's no assigned homework.
I think you're on mute.
Okay. So I'm gonna send this this presentation, this Google Slides, in the WhatsApp, so you guys can practice this all you want. But there's no assigned homework. So okay, graphs and graphing functions. Okay, so this is a really cool concept and stuff. So parts of a graph: slope equals rise over run. Specifically, we're going to be learning about linear graphs and linear equations. We're not going to be learning about the other types of equations yet. Okay, so slope equals rise over run. Y-intercept is where the line touches the y-axis. It's where the graph touches the y-axis. So yeah, let's look at this picture right here. So let me get my annotation tool. So as you can see, parts of the slope-intercept form. This is called the slope-intercept form. It's y equals mx plus b. This is super important. If you're writing down notes, you should definitely write this down. Okay, so if you're writing notes. So yeah, this is the slope-intercept form. It's called that because it includes the slope and the y-intercept. This is the slope. And this is the y-intercept.
Wait, so are there like different classes for each grade, or is it just all the same?
This is just all algebra.
Okay.
Okay. So yeah, that's just the y-intercept. I'm not gonna write it down. It's way too long to write down. Okay, so this is the y-intercept. I'm just gonna write y dash I. So this is the y-intercept. And yeah, these two are just gonna stay here. These are nothing. Those are gonna stay. So you know how this is like a y-axis and this is like an x-axis? That's basically what this is for. That's representing those two axes, kind of. That's not the exact reason. I don't even know the exact reason of why they're here, but that's kind of why they're here. Okay, because they represent like the axes, kind of. So yeah, these two are gonna stay. These M and B are the stuff that you have to worry about. Okay, so as you can see, this is like an example slope-intercept form equation. It's y equals 3, if you can see that, it's y equals 3 over 4 x plus 2. Okay, so yeah, this is the example slope-intercept form equation. Okay, so basically what that's saying is if we graph this, we get this graph right here. So if you look at like the red triangle thing, or yeah, if you look at the red triangle thing, it goes up exactly 1, 2, 3 units up, and 1, 2, 3, 4 units horizontally, right? So that's the slope. It's rise over run. So you know how it goes 3 up? That's where you get this 3 from. And you know how it goes 4 to the side? That's how you get this 4 from. If it went 4 backwards on the horizontal axis, then this would be negative 3 over 4. And that's the same thing as this going 3 down, and when this is going forward. Okay, so that's a little bit complicated, but it doesn't really matter. It's super simple. Pretty much. Okay, so let's talk about the y-intercept. That's exactly what it sounds like. It's where the graph intercepts the y-axis, which for this graph is right here. So that's 2 units. So that's why you're right here. That's where you get this 2 from. So yeah, there's the y-intercept, slope, and yeah, that's pretty much it. So yeah, that's the graphs. They're super simple. Yeah, there's not much to them. Graphing an equation, you have to have the slope-intercept form, and then you have to do all the stuff that we just talked about. So if you have like a slope-intercept form equation, then you can just place a point at the y-intercept. So this is the y-axis, and you're supposed to place a point on the 2 thing of the y-axis. We're going to use this equation. Actually, let's just make up a new equation. Okay, so our new equation is going to be y equals 2x minus 1. Okay, so the y-intercept is minus 1, and that's down here. This is the y-intercept. Then the slope is 2. So since slope is rise over run, right? So it's r rise over run, right? So rise means like how much it goes up, and a whole number is 2 over 1, right? So you have 2 as the rise and 1 as the run. So it goes 2 up, so that's 1, 2, and it goes 1 to the side, 1 right there. So this is going to be the next point. Okay, and we just keep doing that until we get the thing. So that's 2 up, 1 to the side, 2 up, 1 to the side. And you keep plotting the points until you can like do a straight line. And you can even go like the other way. So you have like the 2 down, 1 to the backwards. You can even do that. 2 down, 1 backwards. 2 down, 1 backwards. 2 down, 1 backwards, and so on until you can finally draw a straight line. So place a point over here. Then you can like make a line through all these. And yeah, that's how you plot a graph. It's pretty simple if you know how to do it. I need to save it. So clear it, and we're gonna go on to the next page. Okay, so finally we're going on to the really exciting stuff. Algebra 1, day 4. So again, guys, this is just a review of what we learned last time that we had this class. So yeah, that's why I'm going really fast. The next time we're going to be looking at advanced stuff and more advanced stuff than we learned last time. So then I'm going to be going pretty slow. so you guys can understand everything. The reason I'm going really fast today is because this is just a review of all the stuff we learned last class. So yeah, that's Algebra 1. And Algebra 1, we're going to learn about polynomials, inequalities, nonlinear functions and graphing, statistics, and probability. So yeah, let's keep going. Polynomials are pretty cool. So, oops. Okay, so polynomials. I couldn't really make like a good slide about this because like there's really not much to talk about here. So polynomials, they're just an expression, okay? So they're an expression. So an expression, if you remember from like a lot of slides before, is what an equation is made of. So if you think of an equation like y plus 2 is equal to x minus 2, these individual things right here, these two things are called expressions. They don't have equal signs in them. So this is just one expression. This is another expression. And an equation is two expressions set equal to each other. So yeah, that's what a polynomial is. Sorry, that's not what a polynomial is. So a polynomial is an expression with multiple like terms. So terms are like these singular things that get added or subtracted to other terms. So you have x to the power of 3, then you have 3y minus 6x plus 2y squared plus 2. So yeah, this is a polynomial. It has 4 terms. Sorry, 5 terms. There's even trinomials, which obviously, as you can imagine, are things with only 3 terms. So that's x squared. That's something like x squared plus 2x minus 2 or something like that. See, these have 3 terms right here. Three individual terms. That's why it's called a trinomial, because tri means 3.
So a multi-step equation would count as a trinomial.
I couldn't really hear you, sorry. What's your question?
So a multi-step equation would count as a trinomial.
No. A multi-step equation is an equation. It's not an expression. See, as you can see, this does not have an equal sign anywhere in it. If it has an equal sign in it, then it means it's an equation, not an expression, which is what polynomials and trinomials and binomials are. And as you can imagine, binomials are basically, 2 terms only, binomials. I'm trying to write in cursive so it's easier for me to write. Super bad handwriting. Okay, so binomials, they're just 2 terms, x plus x squared. See, these are 2 different terms, and they're not common. If as you could see, like you can't really add these 2 because these exponents are different. See, this has an exponent of 1. This has an exponent of invisible 1, and this had an exponent of 2. So you can't really add these 2. So yeah, these are binomials, trinomials, and polynomials. These are trinomials and binomials are all polynomials. They're just a smaller part of polynomials, okay? So yeah, does anybody have any questions about that? It's just an expression, basically, polynomials. Okay, that seems like a no. So let's talk about inequalities. So this picture illustrates exactly what inequalities are. As you can see, they're like, not equal to each other. They're like equations, but they're not equal to each other. They're like less than or equal to, less than or greater than, or less than or equal to, or greater than or equal to. which is what these are. See this? This is a less than or equal to. Just like this, just like this, just like this. This is a less than. So yeah, these are all inequalities because they're not equal to each other. That's basically why it's called an inequality. And that's basically what inequalities are. They're super simple stuff. Everybody should know them. Super easy. Okay, so how can we graph an inequality on a number line? So if you only have one variable, then you can graph it on a number line. However, if you have like two variables, then you need a coordinate plane to graph it, because you're gonna get an ordered pair as, you know, as a return value instead of just a number. Hence, you can't graph it on a number line if you have two variables. But this, as you can see, only has one variable, which is x, and so do all of these. They only have one variable. So let's see how we can graph this. So since this does not have an equal to, since this symbol does not have an equal to attached to it, since it's not like a less than or equal to or greater than or equal to, it's just a less than, you don't have to fill this up. And as you can see by these tick marks, if you have it filled up, then this number is also included in the solution. If you don't have it filled up, then there's no check mark over here. So that means it's not included in the solution. This -3, it's not included in the solution. As you can see right here. -3 is not anywhere in here. There's +3, yes, but there's no -3. Because this circle is not filled in. Because this is only a less than, not a less than or equal to. If it has an equal to attached to it, then it has to be filled in. If not, then it doesn't, and that number is not calculated in the thing. Okay, so that's inequalities. They're super simple. You can solve them really easily. Like, yeah, they're super simple. Okay, so I'm just gonna clear out the screen, and we're gonna go on to the next page. So yeah, quadratics. These are. So yeah, the quadratics. So basically, let's see if we. Yeah, quadratic standard form. Okay. So quadratics. So quadratics are basically. I don't really know how. So basically, quadratics, they have. Let's say we have like a variable. Quadratics, they have squared, and they have nothing higher. There's no higher degree to quadratics. So degree means like the highest exponent of the term, the highest total exponent of one term in the expression. So yeah, quadratics have a degree of 2 because they have an x squared, and they do not have anything higher than that. So this can be x squared plus like x plus 1, or it can be just x squared. These are both still considered quadratics because they have x squared in them. Yeah, that's basically what quadratics is. So let's clear the screen. We're getting into some more complicated stuff now. So this is the quadratic standard form. This is the quadratic standard form for graphing like things on a coordinate plane. So yeah, okay, so let's see. So this is the quadratic standard form. It's y equals a x to the power of 2 plus bx plus c. This is the quadratic standard form, and if you're taking notes, you should copy this down. Okay, so how can we solve quadratic equations? Okay, so let's try to solve a simple quadratic equation. Let's say that we have x squared plus trying to think of something good. So that's 9x, and it's going to be plus 18. Okay, this is all equal to 0. So yeah, we can solve this equation by using something called factoring. Okay, so I would have shown you a video about it if I had some more time, but I guess since we don't have much time, I'll just explain it to you. Okay, so factoring, basically what factoring is you have to like factor this into two separate like term things. Like it's pretty hard to explain. I'll just show you how to do it. Okay, so since this is equal to 0, we don't need to add anything onto this side. So how we can factor this is we have to think of a number, of two numbers actually, that multiply to equal this and add up to equal this. So we have to think of factors of this number that add up to this. So let's see, let's think of factors of this number. There's obviously 18 and 1. 18 plus 1 is not 9. So yeah, this is gone. 9 plus 2, because 9 times 2 is 18. 9 plus 2 is obviously gone also, because 9 plus 2 is 11, not 9. Okay, so now let's go on to other stuff, like 6 times 3. 6 times 3 is 18. So 6 plus 3, yes, that equals 9. So yeah, these are the factors. So yeah, now since we have the factors, which is 6 and 3, you can separate this into something that looks like this. There's going to be a parentheses over here, parentheses over here. Okay, so yeah, now you can put 6 right here and 3 right here. And since these are both positive, we can add a positive sign right here and right here, and we can put an x because that's the variable that we're using over here. We can put an x over here and an x over here, and this is all equal to 0. This may seem like magic, but if you multiply these two together by using something called FOIL, which you're also going to be learning in a few minutes, so if you multiply these two together again, then it's going to equal this. Okay, so math is just straight magic, you know. So now you have these two, right? So now how do you get the value of x? So basically what you have to do is, since these are being multiplied to each other and they equal 0, one of them or both of them have to equal to 0. See this x plus 3 right here? It has to equal 0. Or x plus 6 has to equal 0. Or both of them have to equal 0. So we can just set these by themselves to equal to 0. So we can have x plus 6 equals 0 as a separate equation, and x plus 3 equals 0 as a separate equation. Then we can solve these equations by themselves. Let's do this one first. So this is just a one-step equation. We can just solve this equation by doing minus 6 and minus 6 on this side. And then we have x equals negative 6 for this equation. And now let's solve this equation. We have to cancel this 3. We have to subtract 3 from both sides. So that's 0 minus 3, which is negative 3. And we have x is equal to negative 3. So the answer, finally, is x is equal to -6, or x is equal to -3. So there's actually two answers for this that actually work. So yeah, that's how you solve this kind of equation, you know. So yeah, so let's find out how to multiply something like this back together into something like this. Let's find out how to turn something like this into something like this. Okay? So basically, so let's write this, let's just clear the screen. And if you can remember, that's x plus 6 and x plus 3. We're just going to clear the screen and we're going to write out x plus 3 and x plus 6. Put that in parentheses. Put that in parentheses. Perfect. We have exactly what we need. Okay, so as you can remember, this is exactly what we had before. Now we're just going to leave this like an expression. But if you wanted to, you could write an equal to 0 over here if you wanted to. You don't really need it right now, so we're just going to leave it out. So we can multiply this back together using something called FOIL. So that's F O I L. Okay, so FOIL is an acronym for first, outer, inner, and last. So if I just go all the way first, there we go. This is what FOIL stands for. Let's make this black. Perfect. See? First, outer, inner, and last. FOIL is an acronym for that. So what exactly does this mean? So we can, so the first is, as you can imagine, it's the first term of each thing. So these both, this is first, then outer. Outer is the outer terms, so this one right here and this one right here. So like that. Inner, that's obviously this. And last. And now that is this right here, 3 times 6. So now, as you can guess, we just multiply these two like that, according to like the first, outer, inner, and last. First, we have to keep this as a separate term for each of them, okay? So x times x is x squared. If you can remember, two exponents, that's what x squared is. And x squared is x times x, so x times x is x squared. So that's x squared. Then we have outer, and that's x times 6, so that's 6x plus 6x. Then we have inner, 3 times x, so that becomes plus 3x. And we have last, 3 times 6, that's 18, so that's plus 18. So now, as you can see, we're kind of back to where we started. If we simplify this, this becomes x squared. And since these two are common terms, this simplifies to 6 plus 3x, which is 9x. So x squared plus 9x plus 18. That's what we have. That's it. If you can remember, back to where we started, this is exactly what we had before on the left side of the equation. And the right side had 0. So this was before, this was x squared plus 9x plus 18 equals 0. That's what we had before, if you can remember. Back to there. So we're back to where we started. That's how you would use the FOIL method. So this is really important. So if you're taking notes, please write this down. Super important. Okay, so let's go on. Oh, algebra 2 already? Okay, cool. Okay, algebra 2, I guess. So algebra 2 was on day 7. Logarithms, factoring, and systems of equations. So these are all pretty complicated. So we're going to learn them all tomorrow. So yeah, that's it, guys. This is class. It's done. So yeah, I hope you had fun and did everybody understand? What I'm trying to say is, did anybody have any questions about what we
No.
learned? You do?
Can I have the materials of the papers?
Yeah. I'm gonna post it in the WhatsApp group.
Okay.
Soon, yeah.
Bye.
Does anybody else have any questions? Okay, that seems like a no. Okay, so yeah, I guess that's it then. That's it. That's class for today. Bye. See you tomorrow at 7 o'clock.
Bye.
Thank you.
Same link. Bye.
Thank you. Good night. Bye.
Good night to you too.